Happy Valentine's Day, everybody. And happy Ash Wednesday for those of you who go to church. But what I want to do today is part A. Are there any questions about chapter 1? Or chapter 2? Chapter 2. The one we just finished. Are there any questions there? Have y'all been doing the homework on them? Because they opened up the progress reporting and I got to get done by sometime this week. And it's either going to be a U or an S, satisfactory or unsatisfactory. If you're caught up with the homeworks, you'll get a satisfactory. If not, then it's not means you're failing anything. So please catch up. No questions. Go ahead. Where we are in class. Yeah, because the schedule, I always start off very slow in the semesters because math is inductive. Is what you learn today, you'll learn need tomorrow, and so on and so forth. It builds on. So I want to make sure everybody has the same foundation, and then we'll move up faster that way. So yeah, don't worry about it. We'll finish with plenty of time to spare. So if there are any questions over chapter 2, let's start chapter 3. Yes.
So I had asked you about, because it has homework 2.6, and I think you said slip, but I think you meant skip it.
The 2.6 was transformation. It's 2.5. Which one was transformation? 2.5?
Like
modelings. Okay, yeah, skip that one. Yeah.
And then, but that's not on the test either.
That's not on the test. No. Yeah.
No,
Or no, 2.6. Transformations is the last thing we covered in that topic. Right. Because the last section of that has to do with modeling. And that's not it. We could talk about it, but all it is just taking a word problem and put them into words, into math. We'll work on that later. Do you see it on there yet?
You just have to go to test.
That's why I always go to the all assignments. That way you don't worry about it. You see it top down as we go through it. So it makes it much easier. That's why when students say that I didn't see the test. So.
You have all assignments.
Do you see anything?
I think I see.
Questions and times?
Yeah.
But they're under samples, but they're samples.
And so we're not covering section 3, but it says section 3 rectangular knowledge. Is that?
Hold it. Don't do any of those because it didn't take mine then.
The actual quizzes.
Yeah, don't do any tests or quizzes. There will be no quizzes. So don't do any of the quizzes. There's either going to be a practice exam or an exam. So don't take any more of those.
This test for 1, which I already took, but don't do any more.
No, I don't, because it's not the ones I put in there. Because mine will be titled Chapter 2 exam or Chapter 2 practice exam. And in Chapter 2 practice exam will be in parentheses worth 20 points or 10 points bonus. That's how it's mine. So yeah, I'm having trouble with that then. So don't do any more of those. Okay, yeah, I'm sorry about that.
So these are the sample ones.
Yeah, don't do those. They're worth nothing. Yeah. 2 weeks ago, 3. But no, I'll get it up ASAP because yeah, when I get home today, that's ridiculous. It's so many buttons on there. Is your grade book being populated also?
Yeah.
So all the assignments are in there? Okay, good.
Yeah.
So where would you find the grade? I see it in my math lab.
We're going to look at chapter 3, section 1. This one has 3 parts. Shoot.
Because on this little schedule, you don't have any 3. It's like you skipped three.
Are there any homeworks for 3? Just 4? So it's chapter 4, section 1. Polynomial functions. What does the word polynomial mean? Very good. Many numbers. As I was going to, or terms. Because if it was just many numbers, then we could add them and subtract them all together. But yeah, I know what you meant by many numbers, many parts. Is that a polynomial? Yes. Because this is a very ambiguous term. But it is a polynomial. It's in the family of polynomials, but it's got another name. If it only has one term, it's called a what? Only one term. But even better, it has no variables, so it's called a what? A constant function. Now, if it has 2 terms, what's that called?
Binomial.
Binomial. And we'll talk about the properties and characteristics of all these. If it has 3 terms, yes, it has 3 terms. We could keep on going there, but if we had something like this, what would you call that one? Yeah, you would, this would be a quadrinomial, or this is where we start talking about a polynomial of degree, in this case, 3. Because if you notice these things, the degree is the largest exponent. That's the degree. The degree of a polynomial is the largest exponent. Now, the degree tells us a lot about the equation. It tells us the maximum number of solutions by solutions, I mean what? X-intercepts, right? X-intercepts. It tells us the shape of the polynomial. the maximum number of vertices in the polynomial the maximum number of terms possible in the polynomial. Instead of writing the word polynomial, I'm simply going to write P of X. It's like all of this from one little number. That's pretty impressive. Let's look how this is true. What's the graph of the first one look like? Yeah, it's a horizontal line through 3. The second one, it's a line with a positive slope going through 2. So has a point there, up 3 over 1, so it looks like this. This next one is a parabola. Let's say it looks something like this. Or and the next one looks something like this. So now, all the stuff I just talked about. Let's look how it relates to your pictures. How many solutions, how many x-intercepts does the first one have?
Oh, X.
X, none. All y'all have the same answer. Yeah, it cannot have an x-intercept because the function has no x's. So this one has no x-intercepts. Because, well, what's the degree of this one? What's the degree of this one? How many solutions do we have? One. The degree of this one is 2. And it, again, I said the maximum number. Let's see what that means. So if the degree is 2, we can have 2 solutions, 1 solution, or no solutions. If the degree is 3, we can have 3 solutions, two solutions, one solution. So with this, we can take a leap of faith. If the degree is even, How many solutions are possible? From whatever the degree is down to 0. We'll call the degree n. If the degree is odd, then we can have n, but we have to have at least one solution. Why? Because odd degrees, the end behavior is opposite directions. We call that end behavior. Odd degree polynomials, end behavior, they point opposite directions, either up or down. Even degree polynomials, both ends point the same direction. So that's why we can have no solutions possible. But with odd degrees, you have to have at least one. All right, so that's the first thing we look for. So given any polynomial, just by looking at it, what can you tell me? Right? We know that the end behavior is opposite directions. So it's either going to be like this and like this, or it's going to be like this and like this. And whatever happens in the middle, we don't know. How do we tell which one's which? The direction is determined by the leading term. More so, the leading term is the first term in the equation. This is what tells us everything about it. The degree is the highest exponent. And the leading coefficient is a number in front. So typically we'll write leading terms like that. This is a leading term. Because what we're going to do here on this side, the leading coefficient can either be positive or negative. So that's A. And up here is a degree. The degree can either be even or odd. So if the degree is even, we know that the ends point the same direction. If the leading coefficient is positive, they both point up. If it's negative, they both point down. If the degree is odd and the coefficient is positive, then it's an increasing function, which means the left side goes down, the right side goes up. If the leading coefficient is negative, then it's a decreasing function. The graph will look like that. All right, so again, the leading term is pretty powerful. So we know that's positive. It's an odd degree. So we'll have our graph will look like this. What else do we know about the function of the polynomial?
There's three maxims.
The maximum will have maximum of 3 solutions, right? And that's a whole nother topic. That'll take us a while to get on how to solve polynomials of the degree n. We'll do that next time. Okay, so we know we'll have at most 3 solutions. We'll also be able to determine how many positives and how many negatives we're going to have. There's one other thing we can tell on this function, on this polynomial. The y-intercept. Always look for the constant term. So we know the y-intercept is at -2. And we know the graph looks something like that. What happens between there? That's a whole nother topic. That's going to take us the most part of next week. But think about it. Before you came here this morning, did you know that? If I gave you a polynomial, you could say, no. So. Let's see what else. Now, the beautiful thing about after we simplify a polynomial, let's say we get to this. So after factoring the polynomial, we come down to here. What is this going to tell us? X-intercepts. These are our x-intercepts, our solutions. So we know our x-intercepts set each one equal to 0. Or you'll see that it's whatever's inside the parentheses, it's always the opposite. So our first x-intercept is at -2, -1, and 3. And we have one at -2. So we find those. And remember, we knew that it's an increasing polynomial. That means from this point, it goes down from this point, the graph goes up. I also know by looking at this part, the factored form, I know that the graph will do something like this. As opposed to
Plus regardless the y-intercept.
I'm going from this one. Well, from our past information, I'm just pretending that this is our factored form.
Oh.
So because by looking at the polynomial, we'll know the y-intercept. And then we've factored out the polynomial, we find the x-intercepts. We know the degree is 3, so it has opposite directions. And we know that it's gonna look something like this. Now, if I gave you this, how can you tell me the degree is 3? Yes, that's one way. Is there another way? Okay, we'll leave it there right now. But yeah, there's another way. Sketch this graph. Let me go ahead and sketch the graph here. We at least know the x-intercepts. What are the x-intercepts? That's what the function is going to look like. The graph is going to look like. We know that by looking at something called multiplicity. The multiplicity are the exponents of the factored form. In other words, the exponents of these answers. So this one is squared. This one is what? There's one. If I add these two together, I get 3. That's my degree. So the sum of your multiplicities is equal to your degree. The sum of your multiplicities is equal to the degree. Like this one here. It's 1 plus 1 plus 1 equals 3. You are correct. Just look at the x's. X times x times x is x cubed, so the degree is 3. Or we should look at the multiplicities of the parentheses. Now, if I give you this polynomial, we'll go back to this in a second. So what's the factored form of this one? So this one, they're both positive. So it's really x plus 2 squared. Right? What does the graph look like? Parabola like this. Because we only have one x-intercept. So it just touches there. We actually have two of them, but they're the same one. So it just touches there. Which tells us if we have an even multiplicity, the graph bounces at that intercept. If the multiplicity is even, the graph bounces at that intercept. The multiplicity of this one is 1. What does that graph look like? The line crosses the y-axis at 2. This is mx plus b. So it's up 1 over 1. So at the x-intercept, which is at -2, I cross it. So if your multiplicity is odd, the graph crosses at that intercept. So again, once you get to the point of factoring it, you can look at the solutions and tell me what's going to happen at the graph at that point. So we know the directions of the end behavior. We know the y-intercept. And if once we solve it, then once we find the x-intercept, we can say whether it bounces or crosses at that point. All right, let me sketch that graph. So I want you to tell me the x-intercepts, the y-intercept, the degree, and sketch the graph. What's the degree? Three plus one is four, plus two is six, plus two is nine, plus two, so it's 11. So the degree is odd. Which tells us what about the graph? The end behavior points opposite direction. Now, so is it like this or is it like this? Is it increasing or decreasing? Why? All the coefficients of my x's are all positive. So therefore it's increasing. My x-intercepts are at 0, -4, +2, -1, +5. Those are my x-intercepts. Because it's an increasing function, the left side, the graph will go down. The right side, the graph's going to go up. Do we know the y-intercept? It crosses, because if we set all of our x's equal to 0, and then work it out. In other words, if that one wasn't there, it would be 4 times 4 times 1 times 25. It'd be 400. But since that one's 0, it crosses through 0, so the y-intercept is at 0. So at -4, does it cross or bounce? It's an odd, so it crosses. At -1, does it cross or bounce? It crosses. At 0, what does it do? It's an odd exponent, so it crosses. At 2, it bounces. And at 5. There, it looks something like that. To find the accurate distribution of these points, the maximums, we have to plot some points. The beautiful thing about calculus is in order to find where these vertices are, we know this vertex and this vertex. To find these other ones, how would we find them algebraically? Plotting a whole bunch of points. If it was a quadratic equation, the vertex is always midpoint of the two x-intercepts. But it's not true in anything higher than that. You can't always say it's going to be, the midpoint's going to be between, it will be a 3.5. You can't say that because we don't know how the graph behaves. So we just have to plot some points. But in calculus, when we find the vertices, this is where the slope is equal to 0. The vertex, the slope is equal to 0. And we're going to find that the slope is actually our first derivative. We'd find the first derivative and then set that equal to 0. So once we solve that, those would tell us where all of our vertices are. Yes,
Is that using the same kind of line of thinking that we did before using slope of difference points?
yes. And what's that formula called?
Sure. Wait,
Difference.
The difference question. Yeah.
still trying to.
Again, whenever we take calculus with, the difference quotient will be where you start off the class. Which is so funny because you'll start off there and at the end of calculus 3, you'll get back to discussing difference quotient. Everything will ravel down to that. Pretty cool. So. How are you with factoring quadratics? Let's practice. Okay. Here are the procedures for it. Do it in steps. What makes up x squared? X times x. So that's the first thing. What makes the first term? Then we look at the second sign. The only way the second sign can be negative is if what is true? The signs have to be opposite. Because where does this number come from? It comes from this number times this number. The only way it could be negative is if they're opposite signs. Now, since you have opposite signs, the bigger number gets the first sign. Now comes the hard part. We have to figure out what two numbers multiply to equal 14. When you subtract them, you get 5, the middle number. 7 times 2, 7 minus 2. Since the first sign is negative, the 7 goes there. So the intercepts are at -2 and 7. And those are your factor form. x squared plus 8x plus 7. And know the factored form of it. Finished already? This is pretty finished? Yeah. This one's pretty straightforward. What'd you get? What did you get? Very good. What makes up x squared? X and x. The second sign's a plus, so that means both signs are the same. They're both positive. So in this first one, whatever's in front of it, I put down there. One in each one. Now, to figure out the next part, I take the coefficient of the first term, which is 1, multiply it by the last term. So 1 times 7 is 7. What two numbers multiply to give me 7? When I add them, I get 8. And since they're both positive, doesn't matter. Pretty easy. I'm going to ruin that for you. The reason they're easy is because leading coefficient's 1. The fun stops when it changes. Okay, factor that one out. Here are my steps. First, place the leading term minus the square into both parentheses. So we have 2x, 2x. Look at the second sign. If it's a minus, the signs are different. So one's plus, one's minus. If it's positive, signs are same, and they are the first sign. No, yeah, that's if the second sign's a positive. Third step. Multiply A times C. The leading coefficient times the constant. So it's 2 times 12. Find two numbers that multiply to equal A times C, that number. that when you second sign them, in this case, when you subtract them, you get the B term. You get B. That's B. The B is middle number. It's AX squared plus BX plus C. You'll get the coefficient of the middle. So we multiply 2 times 12, got 24. And what two numbers minus each other equal 5? 8 times 3 is 24. 8 minus 3 is 5. If the signs are different, the larger number gets the first sign. So the sign's a plus, so the larger number gets the plus.
I don't think you put 2x in both places, because then you get 4x.
I'm not finished yet. I'm not finished yet. Did I say I'm done? Did I circle the answer? No. Now, factor one or both parentheses. So what can you factor out of the first one? Which gives us x plus 4. Can you factor anything out of the second? Delete the factored number. That's our factor. Oh, now I can circle it. So that's a much easier way to do it, no matter how big the polynomial, the quadratic is. It always works. Don't even worry about trying to figure out what the leading term is. Put that in both of them. Do the same thing we've always done. Multiply, multiply. What equals those? Factor out what you don't need, and what you're left with is the answer. But here's all the steps. Easy peasy. Okay, let's look at another one. There. The first thing we notice, they all have x's. So we can take out an x. Now we can try to factor this other part. So 20x, 20x. Second sign's a plus. That tells us both signs are the same. They're both minus. So now I take the first term and the last term and multiply them. 20 times 15 is 300. So now we gotta figure out what times what equals 300. When I add them, I get 37. So we could do 30 times 10. Nope, that's not gonna work. How about, so let's look at the factors of 300. 30 times 10, we have 2 times 15, 2 times 5, 2 times 3 times 5. Factor it out. Now we pair the numbers up, group the numbers up so that whatever number we get, we add them and we get 37. For example, like 2 times 2 is 4 times 5 is 20. 20 and 5 or 15 is 25. No. Five, no. 25. Oh, there's 5 and 5 is 25. 2 times 2 is 4. 25 and 12. So 25 times 12 is 300. 25 plus 12 is 37. They're both the same signs. It doesn't matter what I put where. Yes, I'm not gonna lie. This is the hardest part of this process. It goes on how well you could multiply and add numbers together. So then what do? What can you factor out of the first one? A 5, so we get 4x minus 5. How about the second one? 4. 4 times 5 is 20. 4 times 3 is 12. So what do you do with the 5 and the 4? Oops, just no. Gotta do that. 5x. And there's the factor form. With practice, it gets easier. Again, if you don't see it off the bat, then break it down to smaller numbers and then see how you could arrange them. So when you multiply numbers, you get the product you're looking for, the sum you're looking for. How about that one? I'll show you both ways. Let's do the way we've been doing it. So we put 2 parentheses. The first term, because if you think about it, this equation looks like this. So the first term goes here and here. The second sign's a minus, which means opposite signs. Take the first and the last number, so it's 4 times 1 equals 4. So what 2 numbers multiply to give me 4? When I subtract them, I get 0. 2 and 2. I can factor out a 2 out of there. I can factor out a 2 out of there. And those are my factors. That's one way you could have done it. The other way you could have done it. Four is made up of 2 squared. So that's 2x squared minus 1 squared. The difference of 2 squares? Remember that rule? A squared minus b squared is a plus b, a minus b. So it's going to be 2x plus 1, 2x minus 1. Don't worry, that's the reason why I'm doing this, to refresh your brains with all the stuff that you forgot in the last 20 years. This one? The difference of 2 squares? Well, that's what I like to use, try to use this one.
I was that close.
You were- That's what I said, you were close. Yes, you had one too many negative sides.
It just